Hi guys. So today we're going to talk about section 11.3 and 11.4. And first we're going to start here with 11.3. So 11.3 is finding the area, which we talked about in a circle. So now we're moving on from circles, and we're going to all these different shapes. All are polygons, which means you're trying to find the area, right? Area is how much is inside, right? How much space it takes up, how much stuff you could put in there. Was on a flat surface. And so first we're going to talk about squares and rectangles. So this should be pretty much review for squares and rectangles. For squares and rectangles, you're just doing length times width. Length times width. All right, and so it doesn't really matter which one you call length, which one you call width. But if we look at this one, let's say this is our length L, and this is our width W. So if we want to do A equals length, oops, I just undid what I did. If we want to do length, because we called length 8, times width 3, you get 24. Again, area is always in units squared. So in this case, we get 24 centimeters squared. Sometimes you'll see it written as just like square centimeters, right? Same thing, either one. Okay, let's move on. Let's look at triangles. Again, triangles, you should have worked with finding their area before. Triangles, we have our area is equal to 1/2 the length of the base times the length of the height. All right, and so base is pretty straightforward. It's just like the flat part. So if we're looking at this triangle, you would have this base. The height is where it gets kind of tricky. So sometimes your height's on the inside, as we see here, but it's got to be perpendicular to your base, right? Perpendicular 90-degree angle with your base, and it's got to be going straight up. So if we look here, this is our height 4. Notice we didn't choose to use 5. I guess that's kind of like saying, if you were measuring your height, would you measure your height if you're leaning versus standing straight up, right? And so we always want to measure our height if we're standing straight up, or if our triangle, we want to go straight up. Once in a while, you'll see like a triangle like this, right? And so your height in that case would lie out here, right? Because we want to go straight down. So whatever this height is the height of your triangle, which I think is in the notes example. All right, so if we try to find the area of this triangle, we have to go 1/2 A equals 1/2 times our base, which is 12, times our height, which is 4. And so if you do 12 times 4 times 0.5, you should get, interesting, we get 24 again. Didn't realize that was going to work out. And notice there are no units on this shape. So we still should make sure we put units squared. All right, so there's no specific units, but since we're talking about area, we still got to make sure we put some kind of units and that they are squared. So that's triangles. Let's keep moving. Kites and rhombuses, right? So we talked about these earlier in the year. We have our rhombus here. Right, looks similar to a square, not exactly, but we have all 4 sides are the same, and all angles are the same. Here we have our kite. Right, notice now we have 2 pair of sides that are the same. Okay, so although it's nice because whether you're looking at a rhombus or a kite, you still have the same area equation. And it is 1/2. This is diagonal 1. Diagonal 1. And this is diagonal 2. Right, and so our diagonals are these things that go through the center of our rhombus, right? So that length would be diagonal 1. That length would be diagonal 2. Same thing for a kite, diagonal 1. diagonal 2, and it's the full distance, right? So sometimes you'll be given this piece, right? So this, let's change color. Sometimes you'll be given this piece and this piece, and so then to get the entire diagonal 1, you'd have to add those two pieces together to get that whole length. So let's look at one here. First, you got to be thinking, okay, what's my shape, right? Because you got to know what area equation to use. And so here we're looking, we've got four sides that are the same. If we go back up here, you're like, okay, maybe it's a rectangle, and all I have to do is length times width. But nope, those don't have 90-degree angles in there. No 90-degree angles. And so we got to say, okay, we should use our rhombus kite area equation. So our rhombus kite area equation is area is equal to 1/2 times, let's call this diagonal 1. So times 6 times, let's call this diagonal 2, right? It's that distance there, times 8. And so we get, this one's interesting, another area of 24. And again, we're given our units, meters. So we want to make sure we put meters squared. So a lot of these, you just got to make sure you know the formula. And again, I'm not asking you to memorize these formulas at all, because it's at your fingertips at the click of a Google, right? So like if you're doing something out in the world and you don't know it, it's not like you're trying to memorize everything, especially now since we have these beautiful smartphones. Just go and be like, all right, area formula for a kite, area formula for a square. So that's what we're going there. All right, let's keep moving. Next, we have the area of a regular polygon, right? So a regular polygon is a shape that has all of the same side lengths, right? We've talked about these before, but let's just review. All of the same length sides, and they also have all of the same angles, right? So all of those angles are all the same, right? And that's where we get this idea of a regular polygon. And so this equation is a little bit more, there's a couple more pieces. We have n is our number of sides, right? So if we were to look at this shape, we've got 1, 2, 3, 4, 5, 6. So n would be 6 in that case. Then we have s. S is your side length. So whatever length this side is, or whatever length that side is, if it's a regular polygon, we know that those are the same. So whatever that side length is our s. And lastly, we have a. And a is kind of like a radius of a polygon, right? And so a is from the center of the polygon out to a side. This is different than center out to a point, right? So our A is not the center to a point, it's the center to a side, right? So in this picture, it depicts it nicely of where that A is. And so again, all we're doing is making sure we can find those in our shape and then plug it into our equation. So let's look at this one. We want to find the area of our regular polygon. So regular means that all of our sides are the same. So if we know one of them, we know all of them. So let's see, we got area is equal to 1/2. Think for a second which one of these values is our A. So our A is our 15, right? Side to center, that distance from side to center. Our number of sides, 1, 2, 3, 4, 5. N is our 5. Times our side length here, which if this side's 18, then we know all of the sides are 18. And so let's go ahead and compute 15 times 0.5 times 5 times 18. You should get an area of 675. What are our units here? Let's see if we erase. Do we have any units? No. So we should still make sure we put units squared for your area. And so all this equation does is it breaks it up into pieces like this, right? Triangles, a bunch of triangles. And it's taking all of those triangles and adding them together. All right, our last shape for today, I know there's been a lot. Our last shape for today is a trapezoid. Um, and so our trapezoid, we've got two parallel sides, right? Parallel side A, parallel side B. Parallel side A, parallel side B. Um, and two sides that connect them, right? These sides aren't necessarily parallel. They're not necessarily congruent. There's just two sides, right? So if we look down here, those definitely aren't the same length. Okay, so we get our area inside of a trapezoid by doing side A, right? The two parallel sides, side A and B. And we do side A plus side B, right? These are parallel sides. A and B are parallel sides. And then we multiply it by the height after we divide by 2. Right, so we add up our two sides, we divide it by 2, and then we multiply it by the height. Again, similar to our triangle, notice we're not choosing this as our height. We're choosing the actual height. And if that confuses you, think about like if you were comparing your height to a friend, and your friend was like slanted over or up on their tippy toes, or doing something to change their height, right? It's not straight up and down. We always talk of height as straight up and down, right? From the floor up to wherever we're measuring. So let's calculate the area of this trapezoid. So in this case, we have area equals our two parallel sides. Hopefully you see that these are two parallel sides. So we've got 6 plus 8 divided by 2, and our height in this case is that 4, so times 4. So I would make sure that I do this portion first. So let's see, 6 plus 8 gets you 14, divided by 2 gets you 7. So we got 7 times 4. So our area of this trapezoid is 28. Any units? No units, so we got units squared.